So in the previous section, we ran some transient simulations and learned how to work with the 555 timers. But now we're going to start adding a few more components to our circuit and so add some more complexity. But first, we're going to start by making a summing amplifier. And so now we're actually going to start introducing op amps and a few more power sources as well. So we're going to go to our component tab, go to draft, component, type in op07. It should default to operational amplifier 07 or OP07. If not, just type in OP07, press enter. I'm gonna zoom out a bit. I'm gonna place it here. I'm gonna add 2 resistors. And I'm gonna start off by making an inverting amplifier and just expand on its complexity later. I'm also gonna add a voltage source here and 2 ground symbols here. And then we're gonna do some connecting. One thing to keep in mind while you're working with operational amplifiers is that they also actually need power sources. And this time I'm going to be adding 2 power sources, a positive and a negative power. And I'm actually going to rotate the negative power source. So it's a bit easier to draw a schematic for. I can also move the text. And I'm going to do some basic connections. So overall, nothing new, nothing we haven't seen before. And we're going to go add some values. So I'm going to make this 1K, 2K. I'm going to add a positive power of 10 volts, a negative power of negative 10. And then let's do a simple DC value of 2. So now I'm expecting an operational amplifier, inverting amplifier with a gain of -2. And just to make sure everything's working fine, I'm going to run a transient simulation at a second. Since it's DC, it's not going to change, so it doesn't matter. And I'm just going to run it. So as we can see, we have a -4 volt output given a 2 volt input. And we can zoom in a bit closer by double clicking just to isolate it. And we can see it's at 2 volts. So we have a working instrument, inverting amplifier, but we're running into the same, I guess, kind of problem, but for now, not really, where wires are overlapping, which is fine for a simple circuit. But let's say we actually wanted to add a bit more complexity to our circuit by maybe stringing it alongside another operational amplifier. So cascading the inputs almost, and I'm going to actually move this down slightly. And so you can imagine that as the circuit gets a bit more complex, one in size, but also the number of components, since now I have to go find different ways of actually connecting to different parts of my circuit. And you can imagine, and this is a bit of an exaggeration maybe, but you can imagine that as your circuits get more complex, it might be hard to keep track of following the wires because of this overlap. And so to fix that, we're going to implement a new way to actually make our circuit diagrams a lot cleaner by ridding the wires entirely. And so we're going to introduce a concept of nets and labels. And so label nets and labels essentially allow us to connect components without using wires. And one thing to note here is that any component is going to be connected if they share the same net name. And so the name is actually very important here. And so I'm going to go to draft and then go to label net. And I'm going to type in V+ for positive voltage. And I'm going to connect it to my positive source. And then I'm going to connect it to the positive input of my op amp as well, positive power supply input, excuse me. And then I'm going to connect it here again for my negative and for the negative supply as well. But I am going to change this negative name to V- to denote negative power, and the same thing for this. And so now anything that is connected to V+ will be connected to the 10 volt power source. Anything connected with V- will be connected to the -10 power source. And just to verify everything's working as fine, we can run the simulation again and see that we're still getting the same outputs as before. So we know we didn't destroy anything, we simply connected things a different way. And this is good because It improves the readability of our circuit. If someone's looking for, hey, what's V plus or what's V minus, we can see that off to the side. Off to the side, here they are. And we can actually extend this even further. I don't need two simulations, I just need one. But if we wanted to extend our circuit even further, we can actually make things a lot more easy to scale, excuse me. And I'm trying to move this, sorry. We can make things a lot easier to scale because now, and I can do that later. There we go. Now every component that has V plus and V minus will be connected to these two power supplies. And so we don't actually have to add new components when we just keep reusing the same components. And this is really helpful for when you have shared sources like shared power rails, or you can even actually connect components to each other. So let's say this is a really complex circuit and you want to split them up into two. You can make the output of one circuit the input of another, as if you wanted to cascade. And I'm going to rename that to something else, as if you wanted to cascade amplifiers, excuse me. Out one. And now the output of this amplifier is connected to this amplifier. And we can run that, and just to make sure we're clear, we get the same result as last time. But now if we check the output of the second amplifier, we see that we have an output of 8 volts. So, and we get that because it's running through the first inverting amplifier and then through the second one. And so it's essentially going from negative and then back to positive. But that's just another way of showing that we can connect more than just power supplies. We can connect different parts of the circuit entirely. So it's a good way to keep your circuit clean, improve readability, but also make routing a lot easier. So I don't recommend using it for everything. I would recommend it for separating different parts of your circuit, or especially if you're using shared power supplies, using that rather than using wires to connect them. As it's an easier process. And as we start to build up our summing amplifier into something that's a bit more complex with a few more components, you'll find that using nets and labels becomes a pretty handy tool to have.